Hi, today we're going to go over Project 3. We're going to start in Lesson 13. Our first problem reads, a bedroom has an area of 3x to the negative second, 4y to the third, all to the third power. The length is 6x to the third, y to the negative fourth, all to the second power. Use the formula area equals width times length to find the width of the room. Submit your answer in simplest form and do not include negative exponents. So we're given the formula area equals width times length. We're given our area and our length and need to solve for our width. So the first thing we want to do is use our power rule. So the power rule takes the 3 and multiplies everything in the parentheses 3 times, or takes it to the third power. So 3 to the third power is 3 times 3 times 3, which is 36. Our power rule states that when we have an exponent raised to an exponent, we multiply those exponents. So x to the negative second to the third power, we multiply the negative 2 times 3 and get x to the negative sixth. We get 4 to the third power. 4 to the third power is 64. We get y to the third power. Y to the third power, we get 3 times 3, which is 9. So we get y to the ninth is equal to width. And then we want to take 6x to the third, y to the negative fourth, all to the second power. So we're going to take 6 and square it, which is 36. X to the third and to the second power is 3 times 2, which is x to the sixth. Y to the negative fourth to the second power is negative 4 times 2, which is negative 8. So we get y to the negative eighth. Now we want to get our width by itself. So in order to do this, we've got to get rid of that 36x to the sixth, y to the negative eighth. When we think about it, what's it doing to the width? Is it adding, subtracting, multiplying, or dividing? Well, it's multiplying. So the opposite of multiplication is division. So we're going to go ahead and divide both sides by 36x to the sixth, y to the negative eighth. Now let's move the negative exponents. So over there on that left-hand side, we have 36x to the negative sixth, 64y to the ninth, over 36x to the sixth, y to the negative eighth. And on the right-hand side, we're left with just our width, because remember, anything divided by itself is just 1, and width times 1 is just width. So now we're going to move our negative exponents. So remember, with a negative exponent, it doesn't make anything else in the problem negative, but we can make the negative exponent go away by moving it to the bottom if it's on top, or to the top if it's on bottom. So switching its position. So notice I took the y to the eighth, let's go back to that. I took the y to the eighth and I moved it to the top. Now I'm going to take my x to the negative sixth and it's on top, so to get rid of the negative, I've got to move it to the bottom. Now we've got rid of all our negative exponents, so let's go ahead and use the product rule. So the product rule says that when we're multiplying exponents with the same, or multiplying bases to a power, so like y, for instance, to the ninth and y to the eighth, we're multiplying there, so we need to add our exponents. So let's go ahead and divide 36 divided by 36, which is 1. 1 times anything is just itself. So that's why we say the 36 cancels each other out, because we have 1 on top and 1 on bottom. So we've got 64, y to the ninth, y to the eighth, x to the sixth on bottom, and x to the sixth on bottom. So we're going to keep the 64, and then y to the 9 plus 8, and then on bottom we're going to add the exponents on the x, so x to the sixth plus 6. So we get 64 y to the 17th over x to the 12th. And now we've got it in simplest form and do not have any negatives, so that would be our final answer. Let's move on to the next problem. The population of Phoenix is about 1 and 328 thousandths times 10 to the 6th. The area of the city has an area of about 1 and 36 hundredths times 10 to the 4th. Find the number of people residing in Phoenix per square mile. Remember, population density is equal to population divided by area. So I'm going to take the population and divide it by area. So there's a couple of different ways of doing it. Really, we're doing the same thing, but I wanted to show you the little bit longer version for now, because this is written in scientific notation. Please note that when something's written in scientific notation, it's got that power of 10, because we have a base 10 system. So when you see that 10 to the 6th and times a number, that's what we call scientific notation. So we've got 1 and 328 thousandths times 10 times 10 times 10 times 10 times 10 times 10. Because remember, that's what 10 to the 6th means. And 1 and 36 hundredths times 10 times 10 times 10 times 10. Now note that we can divide top and bottom. Since we only have multiplication and division, we can divide and multiply in any order. So we're going to go ahead and do 10 divided by 10, which is 1, 10 divided by 10, which is 1, 10 divided by 10, which is 1, 10 divided by 10, which is 1. And we're left with 1 and 328 thousandths times 10 on top, and then on bottom we're left with 1 and 36 hundredths. Then we're going to go ahead and use our calculator and divide those out. And this is what we're left with. Now, because we're multiplying by 10 and we have a base 10 system, we can take our decimal, and multiplying is going to make it bigger. We can take our decimal and move it 2 places to the right, 1 for each 10. So we multiplied it by 1 10 and the second 10. So we get 97 and 647 thousandths. Or the other way you could think about it is moving the 10 to the 4th on top, and remember, if we move it to the top, we just change the sign on our exponent, so it becomes a -4. Then we can go ahead and use our product rule, which says we can simply add 6 plus -4, or it's the same as saying 6 minus 4. And note that we get the same thing. And once again, we would just use the calculator and then multiply that number by 10 to the 2nd. Let's go ahead and go on to lesson 14. So a family digs a hole in their backyard to plant a tree. These holes can be represented by the quadratic formula y equals 3x squared plus 6x minus 1, where the x-axis represents the ground. Find the lowest point of the hole and write it as an ordered pair. So first, we need to find the vertex, because that's going to be our lowest point, and that's what we're trying to find. So we've got our quadratic in what's called standard form, ax squared plus bx minus c. And we went ahead and color-coded those. So a is 3, that orange color, b is our 6, the green color, and c is our constant, which is our 1. Now we have to have an a term be 1 in order to find our x of our vertex. So in order to do that, we've got to get rid of the 3. And turn it into a 1. So 3 divided by 3 would be 1. But we can't just divide that first term by 3. We've got to divide all the terms by 3 to make sure we're keeping it equal. So we get y is equal to 1x squared plus 2x minus 1/3. Then when it's in standard form, we can find x of our vertex by using negative b divided by 2. So we take our b, which is positive 2, so negative 2 divided by 2 is equal to negative 1. So that's going to be the x of our vertex. We're going to go ahead and plug our x in to find our y value. So note that I just go back to the original equation, and we get y equals 3 times negative 1 squared plus 6 times negative 1 minus 1. So 3 times negative 1 squared is 1, so 3 times 1 is 3, plus 6 times negative 1 is negative 6, minus 1. And we finish doing that out. 3 plus negative 6 minus 1 is negative 4. So then we go ahead and write that as an ordered pair, which is negative 1, negative 4. And that's our final answer. Next problem, we want to find the domain and range of the function f of x is equal to x squared minus 6x plus 4. So to help you visualize this, I'm going to go ahead and draw a graph, but please note that you probably won't graph this right at first, because it's a little harder to graph than it seems. But this will just help you understand where domain's coming from and range is coming from. Please also note that the domain is all possible x values and the range is all possible y values. The way I remember that is d comes before r and x comes before y. So domain x, range y. dx and ry. So we've got our graph here. And when we look at possible x values on the graph of the parabola, we realize that all possible x values work. So if you look at that line going through there, at x equals 0, we get 5. Or sorry, it looks like 4. At x equals 5, we get about 0. At x equals 7, it looks like we get about 10. And please note, if I kept going and we chose x equals 10, it would just be off our graph, because that parabola keeps going up and up and up forever, and so we'd eventually hit all the x values. So any number we plug in for x is going to produce a y value. So once again, any number we plug in for x is going to produce a y value. So our range is from negative infinity to infinity. Any number we plug in, it's going to work. Now, when we look at all possible y values, we realize that all y values don't necessarily work. Because if I wanted a y value for at negative 10, I'm not going to get one. There's not going to be a point on my line at negative 10. But if I go to negative 5, so y equals negative 5 is that blue line I have drawn, and I look at everything up, for every y value above negative 5, there's going to be a point on our line. At least one, if not more. So notice that all y values above the y vertex coordinate work. So please note that the vertex is at negative 5. and any values above that -5 are going to work. So now that you kind of see visually what's going on, we need to find the domain and range without looking at the graph, because you're not given the graph on your project. So we are given the formula y equals x squared minus 6x plus 4. And when in standard form, we can find the x of our vertex by using negative b divided by 2. So our b in this case is -6. So double negatives make a positive, so we get 6 divided by 2 is equal to 3. So that's going to be our x of our vertex. Now we can plug our 3 back into our original equation to find our y. So we get 3 squared minus 6 times 3 plus 4, which is 9 minus 18 plus 4, which is equal to -5. So note that we have our vertex of 3, -5. Now that we know y equals -5 is going to be our cutoff line. So once again, I'm just taking the y value of my vertex, and we know that that's our cutoff line. Then we need to know if the parabola opens up or down. This is where we're going to look at our a term. So our a term is that term I have highlighted in orange, which is a positive one in this case. So we know that our parabola opens up. Negative would be opening down. So because our parabola opens up, we know that -5 is going to be the lowest point on our graph. So therefore, all y values bigger than -5 are going to work. So y is greater than -5, or we can write in set notation and we get -5, infinity. So -5 and all numbers above. But that just tells us that nothing below -5 will work. Let's jump to lesson 15. So question 1, this has a lot of steps, and I went ahead and already made a video on this one, so I want you to go ahead and watch that video that I have listed right there. If you have any questions, please let me know, but that's going to be your best resource for answering question 1 in lesson 15. Now let's go to the next one. Multiply and simplify the following expression. 2x squared y to the 4th over 8x to the 4th y to the 7th times 18x to the 3rd y to the -4th over 36x to the 3rd y squared. So there's a couple of different ways that we can do this, but I'm going to go ahead and multiply first. So remember, with multiplication, we can use the product rule. So first I'm just going to multiply my numbers, 2 times 18, and I'm just going to leave them like that. And then x, 2 plus 3, y, 4 minus 4, or if you want to think of it as 4 plus a -4, that's just fine as well. Then on bottom, I write 8 times 36, and then once again, we're adding exponents because we're multiplying. X to the 4 plus 3, y to the 7 plus 2. Then from there, I just went ahead and added. So we get 2 times 18 equal times x to the 5th, y to the 0, over 8 times 36, x to the 7th, y to the 9th. Now we need to work things out top and bottom. So I went ahead and visually did this for you. 2 times 18 is equal to x times, or time, not equal to, 2 times 18 times x times x times x times x, 8 times 36 times x 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 times x, y to the 9th. So we can go ahead and cross things off top and bottom. 2 goes into 36, and on bottom we're left with 18. And on top we have an 18, so 2 times 18 is 36. So 36 divided by 36 is just 1. x divided by x is 1, 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 x divided by x is 1. So now we go ahead and find everything we're left with. So on top, notice that we've crossed everything out. So I want you to think about that. What number is left on top? Does the top just go away? Well, think about it as we have 1 times 1 times 1 times 1 times 1 times 1 times 1 on top, which is 1. So we have the 1 on top, and then the 8 stays on bottom, x squared y to the 9th. Another way you could do it, I went ahead and wrote all the exponents out, but if you want to take the shortcut or easier way, it's what we call our quotient rule. And you can take the bigger number, which is x to the 7th, and it's on bottom. And you can subtract the 5 from it, because x to the 5th is on top. So if we move the x to the 5th to the bottom, it becomes negative. Add our exponents, so 7 minus 5 is going to be x to the 2nd on bottom, y to the 0 on top, so we're just left with y to the 9th on bottom. Thank you for watching. Please finish Project 3. Please message me or text me or email me if you have any questions or concerns. Thanks. Have a great night.